And it gives remarkably good results, I think. And it wasn't before we started and before other people started doing this. It really wasn't obvious it would work, and it does work remarkably well. So now it's working. It gives you this potential for boundary line monitoring to be carried out more widely and for regulations to be smarter. So if you're a regulator in the audience, you could start to say, well, could you have a look at the source apportionment? What does it say the major sources of pollution are? And then you have more chance of doing something about it. So networks of sensors, I didn't really talk about this too much, but if you have more than one sensor, then you can start to think about triangulating sources and really seeing if there is a major source. And then these mobile sources really kind of gives that option of measuring the whole city. And so this drones is a question mark, but maybe that's a way to really raster over your city and get lots of information. But with that, I was going to talk about this, but I'll talk about this another day. So that's just goes to acknowledge a few people, but thank you very much for listening. I'll take questions if people want to. But...
Thank you very much for your presentation. Actually, I was waiting to hear more of the cognitive impacts of particulate matter. I know carbon dioxide has been established to have a cognitive impact on human performance. So right now, what are some of the things you recommend from all that you've done? I've seen you've done a lot of indoor studies in schools and other places. Have you considered in vehicles and the impact it's going to have on the drivers and other occupants?
Yeah, exactly. So we're doing a study with a French group at the moment, actually, which is doing exactly that. So measuring indoor vehicle environments and looking at the cognitive impacts. And of course, cognitive impacts are particularly important when you're driving a car. So even a slight slowing down of your reaction speed makes big sense. So yeah, so we're starting to look in that direction. And again, clearly you have both indoor sources, in-vehicle sources, and the outside air coming in there. But yeah, the cognitive bit, I didn't talk about that too much, but I really, as I say, I was half joking about the Nobel Prize, but about that composition effect. But I think on the cognition bit as well, I think if you really can show that environmental impacts upon cognition, because you know, you've got it at both ends. You've got this acute short-term impact, which we can think about very simply. We can think about reducing IQ by a point or two, and that will have big effects on your economy, right? Just that little change would have huge effects. And then on the other longer term, then as our populations grow older, we've got like neurodegenerative diseases, and that's been linked to things like Alzheimer's and dementia. And not only are they horrible, horrible diseases, you know, they're hugely expensive. So,
Thank you for the presentation. I think I missed a portion. So are you applying those approaches there, positive matrix, negative, and then non? Yeah. Are you applying all of those to the low-cost sensor data?
yeah.
Okay, so no filters to, you don't have filters, just use that and then do the source distribution and then use, okay.
Yeah, so yeah, and it was when we first did it, it was a shot in the dark, really. We weren't necessarily expecting it to work, but it works remarkably well. I mean, it works particularly well in certain circumstances. So it's not as good as the regulatory way when you've got all the chemical information and all the size distribution. Of course, that's going to be better, but you can get an awful lot of information from the sensors.
Maybe just a comment and a word of warning that you know, you can't really do this with all types of low-cost sensors, as I'm sure you know very well. You know, you were presenting OPCs which have that size distribution, but you know, the type of sensors that are typically more like nephelometers, which Dr. Rosalani presented on a little bit, you know, those don't really have the ability to get the size distribution with much accuracy. And it's really confusing because the manufacturer reports that it does have some size distribution information, so it's easy to be fooled. So yeah, I just wanted to kind of throw that out there as well.
No, that is a really good point. And it's a shame, I think we've talked about this before, that the PM10 tends to be a function of the PM2.5. Because if you do get a good measure of the PM10 and the PM2.5, even knowing that ratio can be really helpful to know where it came from. So dust is big, so the PM10 is big. But if essentially all it measures is PM2.5, then good luck.